Hello students, this is Mr. Hart, and in this video I want to talk to you about how we actually use binary in a way that's useful to us as humans. Obviously we understand the computer needs to be able to talk in binary, but the original programmers that worked on computers actually had to speak in binary because they didn't have, nice monitors and stuff like we talked about before. They were using punch cards and other things. And so they had to work directly in binary, which is really hard for us to process. But again, really easy for the computer. And so today we want to talk about how that system has developed so that we can understand binary in some kind of meaningful way. Okay. The first example I want to show you is called ASCII. So what ASCII is it associates every character on your keyboard with a specific binary number. Okay, so I apologize, I'm covering part of the table here. But the most important ones are over on here, actually. So, for example, the number 65 in binary is 100001, I believe. Okay? And if you put that number in binary, according to this table, that is the capital letter A. And likewise, that number 66 in binary is the capital letter B, and so on and so forth. Okay? All the way until you get to 90. And then all the way over here at 97 is all the lowercase numbers, A to Z, etc. So if you want to type a specific character in a program that used ASCII, you use the associated binary number from this table. Okay, so you'd find let's say you were trying to type computer. You'd find the number for 67 for binary, and that'd be C. And then you'd want to go lowercase, so you go all the way over here, down to the O, which is 111, you type the binary number for that. And then you'd find the lowercase m, which is, again, all the way over here, find the binary number for 109, and so on until you type computer. And so, again, those binary numbers make it easy for us to associate English with actual binary digits. Okay? And so, again, you should be able to find all the different characters on your keyboard here. You may be wondering, why is number 32 the first one you start with? Why not like 0 or 0 to 31, any of those? Those are actually reserved for characters that you may not see that are used for formatting, things like tabs and new lines, etc. They are things you can type, but they're not really part of the writing, and so there's some special characters reserved there. Okay. But this is ASCII. It allows us to switch from binary to the English and characters that we're used to. Okay. There's some new ones now, like UTF-8, and I believe there's even UTF-16 that use more digits to go up to higher numbers instead of just 127 all the way over there. Okay. They go up, up to much higher numbers so that you can include international characters, like the Enye symbol in Spanish, and I think it's called the Umlaut in German or other languages. I apologize if I'm messing that up. And even like some Japanese characters and other things like that. So they go much higher, they count much higher, so that it's more international. And that makes much more sense these days anyways, right? Because this is a global system now. And so there are other ones now. ASCII is the oldest, and it just focused on what's on a traditional US keyboard. But just realize you can set up systems to associate any binary number with a character that we can recognize. Okay. The other system I want to talk about today is actually part of a really cool movie called The Martian. Okay. So if you've seen this movie, then you know it's awesome. I love this movie. It's really good. It's also a book. I haven't read it, but I imagine it's also really well done. But let me tell you about the story, and this part of the story that is useful to us. So if you don't know the premise of The Martian, the point is that it's an astronaut that gets stranded on Mars, and his whole goal is to get back to Earth. And so he's trying to find a way, because Earth thinks he's dead, right? Because you're stranded on Mars, you're probably dead. But he needs to let him know that he's still alive and he needs to be rescued. And so he realizes there's this old NASA probe that crashed back in the 90s that he can go dig up. So he goes and finds the crash site of this old probe. He digs it up and he sets it up so that he can start communicating with Earth. Okay. But there's a problem. It's a probe, so it doesn't really have a microphone or any of the stuff you would need to make a Zoom call, So he has to figure out how to communicate. But not only that, it has a camera and no microphone, but he can't even control the camera. Earth controls the camera, that rotates the camera and moves it as would be needed. So my question is, how would you communicate? You're trying to communicate with Earth, and maybe you could signal something, but all you have is a camera that they control. Okay. Well, what he does in the story is pretty brilliant. He gets some signs out, and he writes on the signs, and he puts them at different locations that the camera can see, so they can see the signs on Earth, and then they can rotate the camera back and forth back on Earth with their software, so they can communicate with him, whether they can see him or not, or whatever's on the signs. Okay. And so they rotate the camera to let him know they're receiving him, and they say yes. Okay, and it's really cool. So that's really good that he knows they're receiving a signal. But now, how do you communicate? Now what do you do? If you need to receive long information from Earth about, what they're doing, or when they're going to try and pick him up, and what he needs to do in the meantime, etc., how would you communicate that just by rotating a camera? Well, you could try and set up some kind of letter system or something for them to rotate to. So you could have all the letters in the English language, right? And then maybe some numbers, but that's really hard to distinguish. If you're going to have 36 signs around that camera, how do you know if they're saying the letter A or the letter B, right? It might be really hard to tell. And so what he ends up using is, again, a brilliant system that we're going to talk about called hexadecimal. And so he actually sets up, hexadecimal uses 16 characters. So he sets up 16 signs around the camera so that they can set up the same signs on Earth, rotate the camera appropriately to those different spots. He can write it down, and he gets their message in this hexadecimal system. So again, it's super cool, really interesting. I love the movie. I highly recommend it if you haven't seen it, and you can also read the book. But let's talk about that system that he uses. Okay, and the point I want to make and why I bring up this story is because the brilliance of the hexadecimal system is that it's compact. It's easy to represent a lot of information in a short amount of space. Okay, so this is how it works. Hexadecimal is base 16. Okay, so we've looked at binary base 2 and our regular number system base 10. So why would we want to go above that? Well, the nice thing about base 16 is it happens to line up very nicely with 4 binary numbers. Okay, so if you look at this column right here, okay, these are our binary numbers, 0 to 7 essentially. Okay, and then over here is 8 through 15. And we can associate those numbers with particular hexadecimal numbers. And this is going to be really confusing because we have our regular numbers, we have our binary numbers, and then we have our hexadecimal characters, which also use our regular numbers. But the way you can use or determine a hexadecimal number is because it has this hashtag symbol or the pound symbol in the front. Okay? So the number for 0 in hexadecimal is just the regular 0. The number for 1 in hexadecimal is just the regular 1, and so on all the way until we get to 8, all the way until we get to 10. Then, when we get to the 10th symbol, we use the letter A. So, letter A in hexadecimal represents the number that is the 10th value in hexadecimal. Okay? Then B is the 11th number in hexadecimal, C is the 12th, D is the 13th, E is the 14th, and F is the 15th. Okay? But again, the beauty is it goes from 0 to 15, which represents exactly 4 binary numbers. Okay, so when we're trying to communicate in binary to a machine or, for other reasons we'll talk about in just a second, we don't want to take the time to write out all the binary numbers. It will take too long. It's, and plus it gets confusing. You get lost. 0, 1, 1, 0, 0, 0, 1, 0, 0. just a big long chain of all binary numbers would be really hard to keep track of. But writing those numbers in hexadecimal is still a binary representation, but it's much more compact. Okay. Let me talk about how we write in hexadecimal, and then we'll look at a few more examples. Okay. So we'll come back to why do we use hexadecimal. Let's talk about how we convert it. Okay. And the reason, and this kind of explains why we think about, or why we use hexadecimal as well, but the way we convert it is we think of a lot of information in computers in terms of bytes. Bytes are 8 digits in binary. So 1 digit in binary is what we call a bit. 8 digits in binary is what we call a byte. Okay, and because of the traditional way computers were set up, a lot of things work in terms of bytes. Turns out 8 digits is a really convenient way to represent a lot of things. Okay, for example, ASCII uses about 8 digits of information to represent any of those characters. So that's why things ended up being in bytes. Okay, so it makes it convenient to represent a byte in hexadecimal because you can write the first 4 bits, first 4 digits, as your first hexadecimal number, those first 4 binary numbers, and then you can use the second 4 numbers as your second hexadecimal. So the number in binary, 1, 1, 1, 1, 1, 1, 1, 1, in hexadecimal would be capital F, capital F. Okay? Because that's number 15, which means 1, 1, 1, 1. Okay, let's look at some more examples, and hopefully this becomes clearer and clearer as we try. Okay. So again, we need to have this table in mind as we're converting numbers between binary and hexadecimal. Okay, so I highly recommend having a picture of this on your computer or whatever you need, but you need to have this table in mind when you're converting hexadecimal. Just like we had the placeholders for binary, for moving from base 10 to binary, you'll need this whole table when you're moving from hexadecimal to binary and back. Okay, so let's just convert one number really quickly. Okay, so we're going to convert this hexadecimal number into binary. So B3. So if we look at that table that we were looking at before, okay, I'm going to try and switch back and forth here as best as I can. Okay, we'll see that B is 1, 0, 1, 1. And 3 is 0, 0, 1, 1. Okay, so going back, and if we again rewrite this, the letter B, right, was 1, 0, 1, 1. And the number, or the character 3 was 0, 0, 1, 1. Okay, so our binary number for B3 is 1, 0, 1, 1, 0, 0, 1, 1. It represents those 8 digits. We just break it into those 2 pieces and write them verbatim on the page. Okay, so it's really just a copy and paste. B was this, 3 was that. Those 2 together give us this number. Okay, let's go the other way. The other way is not much harder. So if we have 1, 0, 1, 0, 0, 1, 1, 1, okay, then what we do is we simply break this into 2 pieces. We're just going to cut that down the middle, get 4 digits at a time. And so this is, if you look at your table, this will be the character for A. So we'll do a hashtag to let everyone know this is a hexadecimal number. So this is character A, 1, 0, 1, 0. And then 0, 1, 1, 1, if you look at your table, is the character for 7. Okay, so this number is the hexadecimal number A7. Okay, but all it is just, again, looking at your table, finding 4 digits at a time, and just moving over appropriately, right? 10, 10 was A, and then 0, 1, 1, 1 was 7. Okay, but that's it. You just look at that table, you copy appropriately, whether you're going from hexadecimal to binary or binary to hexadecimal, and it just gives you a really quick way to represent a lot of binary numbers in a short amount of information. Okay? Let me give you one more example of this, and this is what will be on your homework. There's really a useful convention that has come from this, and that's with color codes. Okay? So if you use like a color picker on Photoshop or on a lot of websites, right, you may want to choose a color. If you look at the top, you'll notice that it's often written in a hex code. The reason why is when you see color on the screen, you often heard that, computer can represent millions of colors, and that's true. But the reason, or the way it does that, is it represents a byte, or 8 digits, of the amount of red in the color, 8 digits in the amount of green in the color, and 8 digits in the amount of blue in the color. So it gives 1 byte for red, 1 byte for green, and 1 byte for blue. And those 3 combinations determine which color you end up with. Okay, so let me actually open up this site. I believe I have it open here. And you'll notice as I change the color on the screen, it's telling you how much of it is red, how much of it is green, and how much of it is blue. But we often don't write it as number, number, number. It's much more convenient to write it in its hex form. So in hexadecimal, it is only 6 characters because it's 2 for red, 2 for green, 2 for blue. So hexadecimal 83 is equivalent to the number 131. And the hexadecimal 41 is equivalent to the number 65. And the hexadecimal 33 is equivalent to the number 51. Okay? So this combination, 834133, will always be this particular shade of red. Okay? And again, we can pick any color and see how much red, green, and blue are on it, and we can find the exact hexadecimal that represents it. So it's common in a lot of programs, if you're trying to get a color exactly right from another program or something else you're working on, you copy that hexadecimal code that you're using, and then you can put it exactly into the other program and get the exact same color. Okay, so that's just, again, another example of why we may need to communicate with something that's a very specific configuration, and it has to be in binary, right? But we can use hexadecimal to quickly and compactly explain a lot of information. Okay, so that's part of your homework. So the first part of your homework will be actually converting hexadecimal to binary, which was, again, just looking at that table. The other part will be looking at things like this and seeing how and why we would use hexadecimal for communicating. Okay, but hopefully that all makes sense, and thank you for watching.